The universe is said to be around 23% dark matter, 72% dark energy and 5% ordinary matter. If we don't know what dark matter and dark energy are, where do the percentages come from? Could it be that our models are simply wrong, rather than postulating another asterisk, dark this or that, asterisk? It seems to be another placeholder, like asterisk, the ether, asterisk of the 19th century, for the errors in our theories that will eventually prove the theories to be inaccurate. I haven't heard much from the dark energy skeptics in popular science. Also, it'll be interesting to know how flawed our existing methods of estimation and calculation are and how many more dimensions exist. Maybe a few hundred years down the line we will know that what we see and know currently is nothing we compare to the reality. Maybe there's a lot more things than dark matter and dark energy. The model for the behavior of the universe is reasonably well locked in, and since they would have had an effect on the CMB, we can extract these percentages from it. I have written a small research paper on it, if you would like to take a look, but it sits about at the top of undergraduate level physics. I felt this was covered well in Astrophysics for People in a Hurry, if you have 3 hours to listen. Dark energy and dark matter are nothing more than peaks and troughs in the fabric of the universe. Much like a blanket on a bed, it doesn't lay completely flat. I'm not talking about lazy job either with ceases. That's all it is, just bumps and dips in space-time. Not a physicist, but you just gave me an idea. How does enthalpy work with antimatter? Since it's a complement to matter and matter runs order to disorder, would antimatter possibly be opposite? What if order to disorder with matter is recharging, the world of antimatter, and the Big Bang event is a reversal of the roles? Is it possible that the gravitational constant might not be truly constant throughout the entire universe? Like maybe it is a certain value within our galaxy, solar system, but has a different value elsewhere. This might account for our observations of distant objects seemingly affected by more gravity than possible. Single quote closing square bracket. Related question. Whereas we can weigh ordinary and dark matter by looking at how gravity is affecting visible objects and light itself, what's the equivalent procedure for weighing dark energy? How do we determine what percentage of the energy in the universe is dark energy? Edit. Based on OP's edit, I see I'm actually just rephrasing the original question. Very short summary. Universe is expanding, it shouldn't be. The fact it's expanding means there has to be extra mass and energy hidden somewhere. Astronomers introduce fudge factor, which is the difference between our theoretical calculations and the experimental values. They give the fudge factor a cool name. I know what it is. Has anyone hypothesized that dark matter is all of the matter that has been absorbed by black holes? I'm not particularly educated in this area, so I'm not aware of any fine details, but my current understanding is that matter gets pulled in and compressed to the nth degree. But does it just stay right there and never moves on the other side, or do things drift around? It's the lack of a specific energy needed to make the universe expand given the known circumstances. We then calculate by how much is it off. Huge oversimplification, but maybe it'll help further down the chain.